Hey everyone, welcome back to the 30-day challenge of Python. Today is day 7 and we're diving into the mathematical elegant data structure of sets. Let's get into it. So let's take a look at sets. In Python, a set is unordered, a changeable collection, and it contains unchangeable objects. What does this mean? For a set, we have unordered, which is no indexing, items that don't have positions. It's changeable, so you can add and remove items as you please. It's unique that there's no duplicates of elements that are allowed within lists and tuples. And it contains unchangeable objects like strings, numbers, tuples in itself, but no lists. Let's take a look at this example. When creating a set, you set it with the curved braces rather than the curly braces, because the difference between the two will be a dictionary and not a set. So when you're setting a set, for this example, we're looking at fruits and numbers. With fruits, in the curly braces, we set it as apples, bananas, oranges, as we see, or we list our integer numbers. But the difference between the dictionary and the set will be the semicolon, with specifying the category that will be in the dictionary. When you look at the duplicates of the sets, we can see that colors set with red, green, blue, and then it duplicates again with red and green. When you call the colors by printing out colors, the set will read out with just red, green, and blue. The duplicates are removed. As we know that sets are also unordered, which means the order of which the set will be called, for example fruits, will print out in a random fashion. So it will either read out banana, oranges, apples, or orange, apples, banana every time you recall the set. So it's nice to see that within Python, the set function, duplicates are technically just removed altogether, which is kind of useful in the sense of removing duplicates from your list is kind of insanely difficult in the sense of that you need to now use a loop and conditionals. With sets, it just happens automatically. Now here's where sets become truly useful. Python sets support mathematical set operations that you might remember from, math class in high school, and they prove to be useful in programming as well. In this example, if you look at the operations, these operations are lightning fast, even with thousands of items in them. They're perfect for data analysis, finding common elements, or detecting differences between data sets. In this example, you can see that there are two sets, A and B. If you look at the first set of example block here, unions, all elements from both sets can be called upon with printing the union of A and B. And if you notice that when printing them out, the duplicates that will be removed would be 4, 5, 4, and 5, as both set A and set B contain integers 4 and 5. To print them out, you use obviously you can call upon the mathematical symbols for it with the pipe symbol on the keyboard, just the straight line, or you can call .union and specify the set that you want to unionize with. Intersections, the elements that are common to both sets, which is the ampersand symbol, or you can call it by intersections and specifying the set that you want to intersect with. The difference is the minus operator. That means that it's all elements in A but not in B, which if you look at the set, elements that are in A but not in B will be 1, 2, 3. And you can swap this around, and the elements that are not in A but are in B will be 6, 7, 8, right? And you can call this obviously by the negative operator or the difference, and specifying the set that you want to be calling, that you want to be setting the difference between. And the symmetric difference, the elements in either set but not in both. In other words, what is in A but not in B, and what is in B but not in A, and you can put them in one set by printing them out, is the up arrow, up the hat symbol, or you can just call upon the symmetric difference by typing out symmetric difference and specifying the set. So these operators are obviously lightning fast, and it works instantaneously within Python. So when looking at modifying the set, since sets are changeable, we can modify them. So here's how the methods for working with sets look. So we can start a set off by setting it into fruits. So we contain fruit, the set fruits will contain apples and bananas, and we can add elements to the set by using the add function. As you see here, we're adding oranges, and that will be put into the set. But if you add apples, nothing will happen because apples already exist, because you can't add duplicates. And when you print out or call fruits, the set will be printed out as apples, banana, oranges. So if you want to add multiple elements, you use the update function, and in this function you will specify the list of items or elements that you want to add. As seen here, you will add the grapes, mango, and banana, but again, duplicates are not allowed in sets, so banana will be ignored and the grapes and mangoes will then be added to the set. When removing an element, you have two options of removing with .remove and specifying the element that you wish to remove, or discard and specifying the element you wish to remove. The difference here is that discard is technically safer because it doesn't crash your program if the element doesn't exist. So with remove, it will raise a key error if the element is not found within the set. With discard, it will kind of just ignore or remove the item if it does exist. So essentially, like looking at something that either exists inside the field, and if it does exist inside the field, remove it, and if it doesn't, you can move on, it doesn't matter. And if you look at pop, it's another way to remove elements. Since sets are unordered, the thing that will happen here is that since it's unordered, random things will be removed, random elements will be removed. So in this example, the variable removed is assigned to fruits.pop, which means a random element will be removed. And if you call what was removed by printing out removed and specifying the variable inside the string format, it will remove anything from the last to the first or anything in the middle. And to clear out a set, you just need to call upon the set and say .clear, and the set, everything in the set will be deleted. Now let's look at some of the methods that Python uses for sets. Python gives us obviously some rich set of methods for working with sets, and these are some of them. Membership testing, so checking, like we did before, when checking if an element exists within a list or a tuple. We're doing the same thing with checking if an element exists within a set. And we have two sets, A and B, with A having ordered an ordered tuple of 1, 2, 3, 4, 5, and set B being 4, 5, 6. Now to check if an element exists within a set, you simply call the element that you're looking for. For in this sense, we're looking if 3 exists in set A, we print out 3 in A, and that will be true. And if we're checking in the same set, if 9 exists, it will report back a boolean of false. So for checking membership, the in function returns back a boolean. A subset and a superset will check if the set A is a superset of set B, and that will return false. And you're checking if set B is a subset of set A, that will also return a boolean of false. To see a subset of another set, we're looking at elements that are similar to that set. So for example, set C is equal to 1 to 3. Since elements 1, 2 and 3 exist in the set of set A, we can then say that if we print out C dot E subset of set A, that will return a boolean of true, because all the elements of set C do exist in set A. Looking at disjoint for no common elements, set 6, 7, 8, if we're looking at set A and call upon is disjoint and specifying the set D, it will return true, as there are no common sets within set A in comparison to set D. If we want to copy a set, we're looking at specifying a new variable and assigning that variable a new set name. In this case, we assigning variable E to be a copy of set A, and we just call it like we did before with tuples and lists. We call the tuple, or call the set in this case, specifying dot copy, and we'll copy the exact set of set A. And now the new set will be with a variable E. So some set comprehensions. For squares, if x in the set of x is the exponential of 2, x squared, for example, for every x in range 1 to 6, you will square all those variable values or elements. So the square root of 1 is 1, square root of 2 is 4, square root of 3 is 9, and so on and so forth, up until 5, since we are in the range of 1 to 6. And if you print out the variable squares, you will end up with each of the square root values of each element. So membership testing, the in keyword, is incredibly fast with sets. It's much faster than lists. This is because sets are hashing behind the scenes. So it's behind each of these sets, there's a hash value that is assigned to each indexing value. Now let's see where set solves actual problems in the actual use case of Python. Let's look at the first one, removing duplicates from a list. Very common procedure. You have the variable with a list of names, John, Jane, John, Mike, Jane, John. As you can tell, there are duplicates within this list. So another variable, you can set another variable of unique names with a list and set these names, calling the set with the variable names, which is your list above, and then print out the unique names. And you will notice that the order may vary, but any duplicates will be deleted. The second problem is finding common interest between users. So you have user 1 interest and user 2 interest. These are two different sets. User 1 interest has a set of Python, coding, gaming, music, and user 2 has gaming, movies, Python, travel. And from what you can read, you can already see that gaming and Python are two of the common things between the user interests. Below that, you will then call the variable interests or common interest into a new variable, specifying the interest between user 1 and user 2. You use ampersand. So user 1 interest, ampersand, user 2 interest, and then print out the common interests. It should give you a set that specifies Python and gaming. The next problem is data validation, which is checking all required fields are present. So a set with a variable named required fields with a name, email, and password, and another set with a variable of user data has a name, email, password, and age. Now in the if statement, it is asking for if required fields dot subset user data, print all required fields present. That is the condition for the if statement. Else, to end the if statement block, you then say missing, assign this to required fields minus user data, and you will print out all the missing data that needs to be inputted. So in this case, if you have email that is missing, the else block will be triggered and print out what is missing from the user data, or rather you'll print out what is missing from the required fields. Moving on to the last example, which will be counting unique words in a text. So you have variable text with the string variable hello world, hello Python, world programming. The unique words will be set into a text.split, and when you call the unique words, it should print out like we have before, that there are no duplicates in sets. So it should print out hello world Python programming. Those 4 words, hello world Python programming, should be printed out, since the duplicates of hello and world are in the text string variable. So you can see that these are elegant solutions within Python using sets. What would take multiple lines with loops becomes a simple one-liner code within sets, other than if you're using lists. So there are some advanced concepts to consider. Just when you thought you understood what sets were, there are some immutable cousins of the sets that you need to look at. These are called frozen sets. So to demonstrate, we create some frozen sets already. So we have a variable called regular sets with a set of ordered integers, and then there's a variable called frozen which is assigned frozen set, and specifying in that frozen set condition is the regular set variable. Then you want to print out the frozen set, which will output frozen set with the open parentheses and curly braces specifying what is in the regular set. Now frozen sets are unchangeable, immutable, which means if you add 6, if you use frozen.add 6, it will call up an error, or throw you an error. But in this case, you can actually use it for dictionary keys. So in this example, locations, the frozen set in each part of the dictionary, you can see New York. New York is assigned to Big Apple, and California, or CA, specifying with California, is Golden State. So there in the dictionary you can call upon those sets with the locations. Frozen set also supports operations. So you have two sets of frozen sets here, A and B, specifying 1, 2, 3, 3, 4, 5. And you can unionize them and it will output the frozen set of 1, 2, 3, 4, 5. Frozen sets are perfect when you need an unchangeable set like a dictionary, or when you want to ensure a set doesn't change. Let's look at some of the common errors that causes major big headaches for us when utilizing sets. So the first one is creating empty sets. Usually this is caused between not understanding the difference between an empty set and an empty dictionary. So as you can see, the variables empty dict and empty set is specified here to showcase the difference between the types of data that we are dealing with. A set, you have to specify set with the open parentheses to have an empty set. The second problem is sets that are unordered. So the issue with that is that sets don't actually support indexing. So you can't call upon a set or the index of a set because they are unordered and they are random. So if you call a set, you won't specifically have the correct index of what that set will, what that element will be in that specific indexing of the set. The third problem will be sets can only contain unchangeable elements or immutable elements. So as you see here in the comment, it says invalid set will be having the brackets with, or in other words, a list within the sets. Lists are changeable. Tuples can be put in them. So valid set will be the curly braces, and inside there will be parentheses that we know can be changed. So the tuples, as we know, can also sort of be changed in a way, but we can change the tuple itself rather than an individual element or the list inside the set. So it's best to rather have a separate variable for list and then convert it to a tuple and then set it inside a set, if that makes sense. Then moving on to the last one, which is, it says here, don't rely on order. The order might change between Python versions or runs, so that's only a headache point that you might run into when utilizing sets. But the main part is the specification between dictionary and a set itself. That is kind of the most common error points that you will run into. So, and that's sets. Yeah, you now understand this mathematical powerhouse, from basic operations to real world applications like duplicate removal and data analysis. So here's what to actually expect tomorrow as we move on with the 30 days of Python. Day 8 consists of dictionaries. We will explore key value pairs, which are fundamentals for representing real world objects and structures. So yeah, as you see, we are building a massive comprehensive data structure understanding, which will be perfect for real world use cases later on. So without further ado, I will bid you farewell. I'll see you tomorrow.